Hi guys, Trev here from SpineWise, and today I want to talk to you about balance and dizziness because there's a lot of misinformation out there about balance and dizziness, and a lot of people don't actually understand what balance is actually about and why we actually need it and what this dizziness thing is. So if you're someone who has dizziness or lightheadedness or any of these type of things, then this is something that you need to watch. So to start with, there's a few different forms of dizziness and lightheadedness out there that people aren't really aware of. So the first one is the obvious one, and that's when you stand up and get dizzy as a result. And this is what we call, well, we're often referred to as orthostatic or postural hypertension. And this is not what we're going to talk about today. We'll do a separate video on all that for those people who want that. Just let me know if that's you, and I'll get that done for you. So today what I want to talk to you about is vestibular function in particular, about how it incorporates and what balance actually truly is. And this relates more to those people who get vertigo type issues. So let's break down balance to start with, because balance is not necessarily about understanding how you stand upright. Balance is more about knowing where you are in space. So really, when we start talking about knowing where we are in space, the brain has to have an image of where your arms are, where your legs are, where your head is, where your trunk is, all these type of things to work out where you are. In order to do that, it needs two reference points. It's very, very hard to work out a three-dimensional image of one reference point. So you need at least two reference points. So how does the brain do that? So if we take our person that's standing up here, nice and upright in that position, there's a few things that she's using right now in order to maintain her posture or to maintain her balance as such. So the first thing we have is our eyes. So her eyes are looking to see where she's going, and most importantly, it's looking for straight lines, it's looking for edges, it's looking for the horizon, it's looking for the corners of doors, things like that, and it's referencing you to those areas to work out where you are in space. So vision is the first way, using our ocular reflexes to work out where we are in space. The second is, where is the floor? So we have input coming up from the floor, from her feet, through her knees, through her hips, through the back, through the neck, all the way up to the brain, to let the brain know where each of these joints are so that we can work out where the floor is. So the second thing we use is, where is the floor? And it's a really important thing. And this is why a lot of people tend to feel a lot better when they're barefoot compared to when they're in really thick sneakers or in high heels. One of the reasons is because they feel the floor better, and therefore they have a better sense of where the floor is. The third thing that happens when we lose this is we then end up asking, where is gravity? Where am I in relation to gravity? So we need to know where the gravitational plane is. And this is what we use our vestibular system for, so our balance centers for inside our ears. And all of those things come together to give us and the brain an idea of that three-dimensional image of where we are in space. So how does the ear work? Okay, so if we go deep inside the ear, we basically have three canals. So we have these canals that come through, and these canals basically, they're kind of like little hula hoops. So if you can imagine a hula hoop with a little ball bearing in it, as you roll the hula hoop, the ball bearing always falls to the bottom. And this is what's happening in our canals. So as you tilt your head forward, tilt your head backwards, laterally flex or rotate, what's happening is those little balls are floating in those circles, and that's giving feedback to the brain as to where gravity is and where your movement pattern is. Now in these canals we don't actually use ball bearings. What's in there is a series of fluids that are sodium and potassium based, and as they move they trigger sensory mechanisms which actually send signals back via the nerves to the brain to let us know where rotation is. But it goes a little bit further than that. Because if we're looking at just, imagine our hula hoop is standing here and we tilt it backwards, so we look up, the result of that is the ball moves backwards, which gives us that feeling. But if we also accelerate really quickly and go fast, we throw it forward, the ball will also move backwards. So the brain needs to have an understanding of what is acceleration versus what is head rotation or head movement. And we've got another little structure called a uticle which actually controls that, and acts kind of like a soccer ball on top of a car, one of the old car antennas, and it just flexes forward and backwards, and that picks up acceleration for us as well. So we have this acceleration input coming in, we have this input coming in from the canals itself into the brain, and that gives us our first point of reference, which is, where is gravity? And the second point of reference then becomes the floor, which is, where is the floor? Together we can put them together to work out our three-dimensional image of where we are in space. So there's a lot of a lot of moving parts to this process in order to work that out. So what happens when we go dizzy? Well, there's a lot of different reasons why we can go dizzy, but when we start talking about vertigo, what often happens is that the sensory mechanisms inside here get a little bit confused, and as they get a little bit confused, the brain starts thinking that you're turning when you're not. And this will start causing your eyes to often rotate and move side to side to try and anticipate the movement so that you're always looking straight, and the net result of that is you get this feeling of vertigo. In some people it's a little bit different, where we get information coming from the head one way saying, hey, that you're turning to the right, for instance, and information from your eyes or your feet saying, no, we're not. And we generate this confusion, and as we generate this confusion, the net result of that is the brain doesn't know where you are in space, what's happening, and we get that dizziness feeling as well. So anyway, guys, that's a nice little introduction as to what's happening here with balance and why balance is really so important, because it's not really about staying upright, it's about knowing where you are in space. And this is what allows us to control all of our different functions in our body, such as your blood pressure, your heart rate, your eye movements, all these kind of things really are strongly dependent upon these mechanisms, which is why they are so important. So anyway, guys, if you have any questions with all that stuff, if you want to know how to test this, I've done videos before for you on all that. You can jump onto our video bank on Facebook, and that'll give us some videos on how you can test for all this stuff. But if you have any questions in particular in relation to what's going on with you, just post them up or send me a message. Always happy to help out. Thanks for watching this far in, and I'll catch up in the next vid. Bye for now.